Hi guys, I'm going to show you how to find the correlation in Google Sheets, but you can do this in Excel too. I'm going to show you the long way so you understand the formula, but I'll also show you the shorter way, the quick way, at the end of the video. Now, using Excel for a fancy calculator is very helpful because when you do it by hand in the calculator, you might make some mistakes, and I find it easier to do it this way, and I make less mistakes if I use Excel versus my little hand calculator. But you can use your hand calculator too if you want. So say we have two variables, x and y, and we want to find the correlation between them. And the correlation will be the same if it's either the population correlation or the sample correlation, because the two formulas end up being the same thing because the n's or the n minus 1s cancel out. So to do the formula the long way, you need the deviations for x, which are the numbers of x minus the mean of x, the deviations for y's, which is the y numbers minus the mean of y, and then the products, which is the multiplication of the deviation of x and y for each person. The squared x deviations are just squaring the deviations for x, and the squared y deviations are just squaring the deviations for y. So you need all these things. What I'm going to do first is to find the mean, which is the average for x. We can do just put an equal sign and type out average. And you can see it kind of pops up for you. And then I'm going to open the parentheses, and I'm just going to highlight all my numbers. And then close the parentheses. So now I have the mean of x, which is 3. And then I'm going to do the same thing for y, because we need the average to find the deviations. Okay, voila. Then press enter. And then the average for y is 5. Now I'm going to find the deviations for x. Now we're going to do the first one first. So we want to know if this person, what their deviation is. So the rows are the people. So for this person who had a 2 for x, we're going to find their deviation for x. So we're going to subtract off the mean, which we found down here. Now we're going to do a little trick, and we're going to put a $sign in front of the letter and also in front of the number for the mean. So the second number here. And what that's going to do is it's going to allow us to just go here and drag this down. So I'm just going to the right bottom corner and dragging it down. And now what happens is this stays the same. It doesn't change. If we did not have that, I'll show you what happens. So say I go up here and remove the $signs. That'll still say A5, but when you bring this down, see it change. Now it's going A6, A7, so it goes down by 1 if you don't have those $signs. So the $signs here just means I want to use this every time. I want to use that exact row every time. And so when you find the deviations, that is very helpful. So I'm just going to drag that down. And now we have the deviation. So this is this number minus the mean, which is -1. And then this is this number minus the mean. And this one is the 4 minus the mean. So we get 1. Alright, now let's do it for y. So we're going to do first y minus its mean and put the $signs. Oh, whoops, I messed that up a little bit. We want B5 with the $signs. Okay, And then I'm going to drag that down. Oh, now I have the deviation. So it's just y, the y minus its mean. Okay. Then we want the products. The products are the deviations of x times the deviation for y. So the multiplication sign in Excel or Google Sheets is the star. And so I'm just going to times it. No dollar signs here because I do want it to change each time. So we're going to multiply across the rows, or across each row here. And then I'm going to pull this down, and now it fills it out. But see how now this is C3 times D3. So it changes each time. And this one is C4 times D4. And you see the colors. It's color-coded for you. All right, awesome. Then we want to find the sum of the products, because that's part of our formula. So we're going to type in sum, and then just highlight all the products. Oops. Just want to go from here to here. Close the parentheses, press enter. So the sum of the products is -2. Now we want to square each of the deviations for x. So to square or put it to whatever power, you want to do the little caret sign, which is shift 6, and then put a 2. So we're going to square the -1 over there. Press enter. And then we want to drag that down because we want to do it for all the x's. So you see this one is that squared, and this one is the 1 squared. Great. And then we want the sum of the x, the squares for the x, because that's going to go in the bottom of the formula. And then we want to do the same thing for the y's. So we're going to square each of the y deviations. Okay, and then I'm going to drag it down so it automatically does it for me. So that's the beauty of Excel. I'll just do it all for you. And then I'm going to add those all up and get the sum of the squares for y. And then I had a border here before, and I'm just going to add it back. Here we go. Alright, so we have the sum of the products. We have the sum of the squares for x and sum of the squares for y. Alright, and then if you look at the formula, it's going to be the sum of the products divided by, so that's / is division in Excel, divided by the square root. And for square root, you just do SQRT and then open the parentheses. And then it's the product of the squares for x times, oops, I'm sorry, kind of doing this one-handed, times the sum of the squares for y. So it's the sum of the products divided by the square root of the sum of the squares for x times the sum of the squares for y. Alright, and then I'm just press enter. We get -0.5. Now to check this, which is really easy, and you can do this on your test if you want, is to use this function, CORREL, open the parentheses, and then highlight your x values, I'm sorry, and then put a comma and highlight your y values. Close your parentheses, and voila, we get the same answer. So this is a good way to find the correlation, and that's a really easy way, and this was the longer way, but the longer way helps you understand the formula. Because on top we have how x and y move together, and on the bottom we have how much variance or variability there is in x by itself and how much variability we have in y by itself. And by dividing the sum of the products, how they move together, by the product of these two, then we and we square those two, the product of those two, we get a standardized measure that goes from -1 to 1. So this is how they move together, and this is how x moves by itself, or how much variability of x there is, how much variability of y there is. And so if you take this and then divide by the square root of their product over here, then we standardize the covariance. And so now we have a correlation that goes from -1 to 1, and you can see this is a pretty strong correlation for psychology. It might be kind of weak for other things like physics or something. I'm not sure how strong this would be, but in psychology, this is pretty strong because we're studying psychological things, and those are hard to measure, and people are complex. So a -0.5 or a +0.5 is actually pretty strong. Alright, I hope that helps you. Usually what happens when you're doing this formula is you do something really small, and that messes up all your numbers and makes you mess up this formula. Alright, that's all I have.